Hi, I'm Alex Anthony, and I work at Alpha. We make software for the asset finance industry, so our clients might lease you a car or a tractor or a container ship. We have a Java backend, but I mostly work on our React-based front-end code. I'm here to talk about a pretty common tool in the front-end armory, ESLint. Can I see a quick show of hands for who uses ESLint? Pretty much everyone. It's built in to create React app. It's one of the things in most tutorials on how to set up your own build config. Gets 7 million downloads a week, which is more than React. If anyone doesn't know, it's a static code analysis tool for JavaScript. So why do we use ESLint? It helps us to avoid errors, such as spotting undefined variables. It helps us to code in a consistent style, so that's our semicolons, indentation, etc. And it helps us to keep our code tidy, so prevents us having unreachable code. Most people either use the default ESLint config or the super popular ESLint config from Airbnb. If you're using React, which I expect you are, the React ESLint plugin has a decent set of defaults. And if you're using Prettier, you can wire that up to basically solve all of your formatting issues. If you're just using one of these standard ESLint configs, you're not really necessarily using the full power of ESLint. So you can start by looking at existing plugins and seeing what's available that isn't in the default or recommended configurations for these. But you can go further than this. You probably have team opinions on coding style that you pass from developer to developer. And they're often unwritten rules that you either pass verbally or in code reviews. These are often things that you can actually be systematic about, which is what computers are really good at. So we can make our lives easier as long as we can encode those rules. So that's what we're going to do. Before we get started on the solution, I'm going to describe the problem. For the sake of this talk, I'm going to pick out a nitpick, so it's not a really serious problem, because it's a good example to demonstrate. But this could equally be applied to things that add more value than this, preventing errors and making our code actually better. This is based on a real nitpick that I had in a code review and concluded that it was the sort of thing a computer could actually spot. I assume that most people here are familiar with fragments, just these wrapper elements that they don't actually add anything to the DOM. Some of you probably remember doing this sort of inline conditional logic before fragments, so you'd have to add a wrapper div or repeat the conditional logic twice. But then we got React 16.2, that all went away, and everything was great. Until someone came and extracted that button and that other thing into one component. We've still got this fragment kicking around. It's not doing any harm, but it's a bit untidy. Slightly contrived example here because you can quite clearly see it, but if that button and that other thing had a longer list of props, it might be a bit harder to notice. So I spotted that a developer had done this, passed it back to him, and asked him to just quickly tidy it up. But imagine if CI had done this for me, or even if it had just been highlighted in the developer's editor at the time. I wouldn't have had to get involved and send it back, and the whole thing would have just gone straight through. So I thought about this, and then did what any lazy developer would do. I went and asked Google if it had already been done. The React ESLint plugin does have a fragment rule, but it doesn't enforce this. It just enforces that you use the same style, either the long form or the short form. So I decided to try and write the rule myself. ESLint rules are grouped into plugins, which can also include a config to use those rules. I was just creating a single rule, but I wanted to use it quickly, so not wait for it to pull request into someone else's config, merge it, upgrade our code to use their one. So I just created my own plugin. Fortunately, there are tools that can do most of this for us. Creating a new ESLint plugin is really easy. It's these 4 commands. This is using a tool called Yeoman, which you may have come across, although don't see it as much as I did a few years ago. Yeoman. Basically, it does a job a bit like Create React App, helping to scaffold new projects based on generators, which are just elaborate templates. We're using the ESLint generator, which is cleverly titled Generator ESLint. I've installed these globally because they're tools to set up our project rather than being part of the project itself. We can then run the generator with the plugin suffix to tell it to create a plugin. It asks us a couple of questions: what's the package name, description, and then it sets up an empty project for us. Unfortunately, the generator is a little bit out of date. We like the latest and greatest. So first thing I did was dive in and actually upgrade ESLint in the plugin to use the one we're using in our project. Creating a new rule is even easier. So still using the ESLint generator, but this time creating a rule. We get asked for some details of the rule, this time including an example of code that's going to fail the rule. So I went for the simplest code I could come up with that would make it fail, this single div in a fragment. Running this command sets up three things for us. We get an empty rule in lib/rules, a markdown file, because it's important to document this, and the beginnings of a unit test in the test folder. Before we can write our code, we just need to know a bit more about how ESLint works. It parses our source code files and turns them into what's called an abstract syntax tree, or AST. This is basically a representation of our source code as a tree of objects. That might not make much sense without an example, so here's a simple one. On the left, we have a really simple bit of JavaScript, and on the right, we have a cut-down version of the AST representing this. We have a variable declaration at the top of kind const, and this is made up of an identifier, val, and an initial value, which is a binary expression with two literals and an operator. ASTs get pretty crazy when you point them at real code, so fortunately there's a good tool to explore them called AST Explorer. I've set it to use ESLint at the top, which is what ESLint uses to parse our code. We can type then any bit of code on the left and click on it to highlight the corresponding value in the AST on the right. Here I've clicked on one of the fragments in my bad component, and I can see I've got a JSX element with a JSX opening element inside it. So this is basically how ESLint reads our code. It looks for particular patterns and structures in the AST and reports an issue if it finds something that breaks its rules. While we're writing our rule, we want to be able to easily test it without having to publish a package and actually run the whole lot on our code. So the easiest way to do this is to write unit tests. We've already got one, which the Yeoman generator set up for us. And ESLint comes with a great test framework already called rule test. Sorry. The generator added Mocha to run these tests, but they actually work fine with any common unit test library. Because I'm used to it, I just decided to switch it to Jest. And I've also set up Babel in the project with the env and React presets, just because out of the box ESLint can't pass JSX. So here's the unit test that it set up for me, with the exception of the imports at the top. And I've added the parser Babel ESLint, which took me ages to work out. We pass it the code to test as a string, and it's already populated that with the piece of code that we told it before. And for the invalid option, it tells us what we have to provide, what error message we want to provide along with it, and what bit of code it should be pointing at, which is the type. So that's how in your editor it can work out where to point the error when you get. We can now, with this, set up Jest in watch mode and just keep running our test while we're working on our rule, so we'll know when we sorted it and made it pass. So we've got our plugin and rule templated, and we've got our unit test, so now we can actually write our rule. So ESLint rules are based on the visitor pattern, which basically means the rule is an object where the keys are AST node types, and the values are functions that it calls with any nodes of that type to decide if they're valid. So we already saw in AST Explorer that our fragment in JSX was a node with type JSX element. So to begin with, let's listen for JSX element nodes. This is all a rule actually is. So we've got some metadata at the top, which is static and makes sense when I don't cut it out. And then we have a function to create our rule functionality, which returns an object. And in the object, the keys are node types like JSX element, and they are then functions. The context bit is what we use when we actually want to report any errors. So if we want to report an error for every JSX element, we do something like that. If we look at our test output now, it's not going to be passing because, first of all, we told it that the message was going to be fill me in, and it's remove redundant fragment, and that the node type would be me too, and it's going to be JSX element. So if we change the test to fix those bits, then we get pretty close to passing, but it's still failing because it's currently reporting on every JSX element, which is both the fragment and the div. So we go back to the AST to work out how to identify just the fragment. So here's the AST for the fragment in a bit more detail. So inside our JSX element, we have a JSX opening element. Inside that, we have a JSX identifier, and that has a property name, which is the string fragment. So now we know how to spot a fragment. Opening element .name is the string fragment. So the AST is just a JavaScript object, and rules are just plain JavaScript, so writing our rule is quite easy. Node.opening element.name is fragment. And then we can see that our test is passing. Great. So now in true TDD style, we can add a new test that's going to fail and then update our code to make it pass. So we know that our code at the moment is a bit overzealous. It's reporting any fragment in the code at all. So the best test we can do at the moment is a piece of valid code using a fragment that we should ignore. So we go for the simplest example of that, where we've got two divs. So again, just passing the code to check as a string and pass a Babel ESLint. And this time we don't have to pass an expected error because we're expecting it to be valid. This is going to fail, and so we can look at what's required. It's the number of children. So we go back to the AST. And so as well as the opening element and closing element, we have an array of children on our JSX element. So the logic for our rule is pretty simple. 2 or more children is valid, 1 or no children is invalid. Just a JavaScript object in an array. Node.children.length is less than or equal to 1. So this makes our test pass. And so this is basically all we have to do to write our rule. Just keep finding a case that it doesn't handle properly, and then tweak our rule to handle it. So in our internal version, I've made a few further tweaks to this. Rather than reporting the error against the JSX element, it actually looks nicer in your editor if you report it against just the opening element. You don't highlight the entire thing. When the code is properly indented, the white space is included in the array of children, so we can just filter that out. And I've been using just the word fragment for my fragments. You could also have that as react.fragment or as the Babel shorthand double angle bracket thing if you've got a recent Babel version. So if you handle all of those, you end up with something a bit like this. It looks quite different, mainly because I've extracted stuff out into functions, but at the bottom we're still doing pretty much the same thing with JSX element, but now also handling JSX fragment, which is just the fragment shorthand. The isFragment function handles our existing one and the React.fragment pattern, which is a member expression, and has 1 or 0 children, ignores the literals that are the white space, and when we're reporting an error, we report it against node.openingElement, not just node. The one extra bit we can do is write a function that will fix the linter error. The main principle here is to do as little as possible. So we're not going to try and reformat the code. We're going to leave that to Prettier and our ESLint rules about formatting. All we want to do is delete the opening and closing elements. So our fixing function, we pass that with the error report, and it gives us this fixer helper, which allows us to interact with the AST, which then gets written back as the source code. So there isn't much detail to go onto here other than we remove the opening element and the closing element. The test framework also has support for checking that the fix function does the right thing. You basically provide the code that you'd expect to see once it's been fixed. The last thing we have to do is actually use our rule. So add it to our project's ESLint config. We can publish our plugin as an npm package internally, externally, just install it as a Git repo, local file path, leave that bit up to you. But then we just need to tell ESLint to load up our plugin, put it in the plugins array, and to treat our rule as an error, so code 2. 0 is accept, 1 is warn. We can leave off ESLint plugin from the start of the plugin name, so I've just gone for React London. And you just have to make sure you include the plugin name as the start of the rule name. So once you've done this once, writing a rule becomes much easier, and you just start iterating on the AST and a unit test. And once you've written and applied the rule, you don't have to worry about that in a code review ever again. And here it is working in my editor with my rule. Thanks for listening. Hopefully we've still got some time for some questions if anyone has any.
I'd just like to ask you to publish it on GitHub because I've got a team that could very much benefit from it.
Yeah, I'll look into it. I need to work out what I need to do for that at work. I haven't published anything yet. But...
Any other questions?
Is Yeoman something like Yarn?
No, it's not. It's a tool that does scaffolding in the way that Create React App scaffolds a React project. So it's a templating thing. So you run it and it produces an empty npm package for you.
Like Create React App?
So Create React App, you run that and it creates you a new React application. Yeoman, people can write generators for it and it will create npm modules of all different sorts.
Okay, thank
you. What are the React-specific rules have you created?
So in our team, we use Enzyme, and sometimes Enzyme's too powerful. It lets you do a load of interrogating the internal state of a component. So we've got a rule that prevents you from interacting too much with the state in unit test. Those are the two that I've got round to at the moment. Got a couple of other ideas that I'm working on.
So a little bit of context. When we create a PR at our company, we have plenty of services that are hooked up to the PR. One of them is Codacy. And Codacy accepts not only default ESLint rules, but custom ones as well. and it literally runs over the project and tells you if everything fits the rules or not. And my question is, are you aware if your custom rule would actually be later on supported by some services that actually read it from the file that you specify with your custom config?
I
Not
haven't.
only in your editor, I mean, of course, while you run it locally as an installed package, it would work. But if you feed in your ESLint config that's going to use your plugin, would third-party services?
Yeah, we have it set up in and hooked up into our CI, and it works just like any other ESLint plugin. I think it would only work if you're set up using actually running ESLint. I think you were suggesting that maybe it does something slightly different, but
Roughly Courtesy does that thing, I assume.
if it's actually just running ESLint, then it definitely works because that's all that
Sweet,
ESLint rules
cheers.
are.
Cool. I think that's all the questions that we have. Thanks again, Alex, for a great talk on ESLint and all the things involved.